Hello friends, I hope you all are doing well. So in today's session, we'll do lab on destination NAT with session distribution, right? So our topology remains the same. We will start directly with the lab in this. So what we are going to achieve in this is basically we have our internet PC, right? So from the internet PC, will telnet into firewall, and the firewall in turn is going to do a destination NAT, whereas in this case we are going to distribute this session amongst these three PCs. Is like if we are selecting a round robin, the session would get distributed to each PC. If we are doing a IP hash base, then the traffic will get assigned to particular PC based of the hash value. Then there is one more type called least connection and IP modulus. So we will do how to configure them, and let's see how it works. Okay, so let's take let's log into the firewall. Okay, here is our firewall. So first let's create a NAT policy. So let's create a NAT policy for dynamic DNAT. Okay, so original source zone would be the egress, right? Destination zone would also be egress, and source address is like our PC on internet, that is 1.1.1.2, and destination address is our 1.1.1.1. Okay, so this is S1, and now under destination address translation type, we will select as dynamic IP with session distribution. Okay, so the translated address in this case, what we will do is I have created an address group called HTTP server, in which you can see that these three 10.5, 10.6 and 10.7, these three PCs that we mentioned, those are added. So we are going to select that, and then the session distribution method, initially let's test with round robin. Okay, so this is how the configuration would look like. Then let's come to security. On the security side, again we need to create a DNAT security policy. Would be then the source zone would be the original source zone, it would be a egress, and the source address, it needs to be the original source address, that is the pre-NAT IP. We are going to keep it 1.1.1.2. Then destination zone, it's going to land into the egress zone, that is the zone in which the finally packet is going to come in, which is like this one, 192.168, 10.5, 10.6. It's going to be the ingress zone, and then the destination. So destination, it's going to hit firewall, so it is going to be original pre-NAT IP. So application, we are going to keep it any. Services, let's do it any. Action, by default allow. So this is how our security policy would look like. Traffic coming from egress with IP of 1.1.2 going to ingress zone with 1.1.1.1. Let's do commit, and let's open up session to internet. PC. So what we are going to do is we are going to run a telnet to 1.1.1.1, and ideally it should distribute session to each PCs shown in the figure. Okay, let's see if commit is completed. Right. Now let's do telnet to 1.1.1.1 for port 80. Now the session is open. Let's take a look at this one. Okay, now we can see that at this time the session has gone to 10.5. Okay, so let's disconnect this one and again initiate the connection. Okay, now let's see. Now this time it has gone to 10.7. Okay, so okay, now let's initiate one more session and see it goes to which. So it went to 5 again this time. So in this way actually it distributes the session to each firewall. So okay, let's check now. It went to 7. Let's cancel. It went to 5 again. Okay, let's quickly take a look at dynamic distribution round robin. What's the problem? Just want to see what's the problem with 6, as I don't see any session coming on. Ah, there you see the HTTPS status is disabled. That's the reason there is no traffic coming on this one. Okay, now let's take a look at it again. Show IP HTTP status. Show IP HTTP server status. So it is enabled this time. Okay, so now let's initiate the connection and see how it looks. Let's clear all the session. Clear session all. Okay, Fine. Now let's initiate telnet. Let's see where. Okay, so this time it went to 10.5. Let's initiate again. Now let's check. This time it went to 10.6. Now let's initiate the connection again. So it went to 10.7 this time. So that shows like our round robin pattern is working fine, right? So next distribution type we will take a look at source IP hash. So basically what a source IP hash it does is based off source IP, it creates one unique hash key. Then this key is used basically to allocate client to a particular server. So the use case may be like, there is already a connection with particular server and there is any interruption in IP traffic and the connection got lost. So for some application, it is useful that the connection client initiate it if it goes to server, it would be better. So in those cases, actually source IP hash would be useful. But in a case like, if you have a single source IP, then that would, not be helpful because it would always go to one server. So let's see how this one works. Source IP hash. Let's do commit and let's come here on the internet PC. Let's stop the connection on firewall. Let's check. It will time out in few seconds. Okay, so now the commit is done. Let's initiate connection from internet PC and let's see where it went. So we can see that now it is on 10.7. Okay, let's stop the connection. Okay, so let's check session. Let's clear the session. Let's check no session, right? So now let's initiate the connection again, and as per source IP hash, it should go to 10.7 again. So yeah, that looks fine. It went to 10.7 again. So that is what basically the function of source IP hash. Right. Next one they have here is IP modulus, IP hash, and lease session. So basically, IP hash is in source IP hash. It basically calculates the hash value based off source IP only, and in IP hash, it calculates the hash value based off source and destination, and based off that, the session is passed to particular server. And then IP modulus is basically it considers again the source destination IP and it performs the XOR operations and modulo operation, and based off that it sends the session to particular server. So it is IP modulo, we can say, is kind of I mean it will send the traffic once to let's say server 1, other time to server 2, based off the algorithm it runs. So it's not like kind of source IP destination IP hash wherein it checks the initial connection and sends traffic to particular server. So these are like that. And then least connection, as the name suggests, the firewall monitors basically which destination server is having the least session, and then based off that it sends connection to the server which is having least session. So these are basically destination translation like with session distribution that Palo Alto they have. So that's all for this session. If you have any questions, please comment. Thanks for now. You have a good day. Bye.